Hi, I didn't see you there. Well, since we're here, why don't I show you a little experiment that we can do? For my experiment, I'm going to take a standard deck of cards. I'm going to take a card out of my stack of cards at random. I'm going to put it back in, shuffle my deck of cards again, and then do it again. I'm going to pick 10 cards out of my deck of cards in this manner, and I'm going to write down if I get a black card or a red. Now, before we start, let's think about what happens when I do this experiment a bunch of times. I would expect if I did this experiment a lot of times, I would think that I would get an average of about 5 black cards and 5 red cards. My hypothesis is that the mean number of black cards that I get is going to be 5, right? Okay. Now, I really don't know anything about this experiment, but I can make a suggestion about. Now, I've already shuffled my deck of cards, so I'm just going to pick a card out of my stack without looking at them. Whoop. Looks like I have a black card. Yep, another black card. Shuffled again. Another black card. 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 Now, wait a minute. I didn't get what I expected to get. I expected to get 5 black cards, right? But I got 10 black. I expected to get 5 black cards, but I actually got 10 black cards. Now let's talk about what actually happened here. Ask some questions to my good friend Tommy over here. Hi, my name's Tommy. All right, Tommy, do you believe that there is a 50% chance for drawing a black card with this deck? I don't believe that this deck is 50% black cards because you got 10 black cards. Thanks, Tommy. Now, is it possible that a person with a normal deck of cards, so maybe this is a normal deck of cards, do you think it's possible that someone could have pulled out 10 black cards in a row? Yeah, but it wouldn't be very likely, would it? No, right? It is possible that I could pull 10 black cards out of a normal deck of cards, but we would never really expect that to happen. Of course, it is probable, but it probably wouldn't happen. Okay, Tommy, thanks for. All right, peace out. In our experiment, we had 2 contradictory pieces of information, which I talked about before. Our claim, which was our hypothesis, told us that there were going to be 5 black cards in our deck, or that the mean would be 5. Now, in reality, or what happened in our experiment, is that we didn't get 10 black cards, right? So we did not get 5 black cards. Okay, our conclusion was that, well, the deck isn't 50-50. What would you conclude if I had, say, 9 black cards and 1 red card? I think at this point you would still throw out the evidence. What about 8 and 2? Maybe you'd be slightly suspicious, but you wouldn't immediately throw out the hypothesis. And what about 7 and 3? Here it gets a little bit more wishy-washy, right? It actually does seem pretty probable that we could get 7 black cards and 3 red cards. So there's kind of a fine line of where the cutoff is as to if we throw out our hypothesis or if we decide to keep it. This is the whole idea behind hypothesis testing. Okay, first we set up a hypothesis, like that the mean is equal to 5. And we already assume that it's true. We have no doubts that it's going to fail. Then we do this experiment where we gather data from some sort of real world thing that happens, like me picking 10 cards out of a stack. And we compare it to the hypothesis and see how close it follows it. Finally, based on our results, we make some sort of determination or conclusion from our hypothesis, we make some sort of conclusion based on the idea of how likely is our hypothesis based on this evidence. In my experiment, there were only two things that could have happened. I could have concluded that, well, the mean would be 5 black cards, or the mean would not be 5 black cards, okay? Whenever we make a conclusion about something, or whenever we make a hypothesis about something in our class, we're always going to be thinking about the population mean. So our hypothesis is always going to talk about the population mean and guess what it's going to be equal to. Now we call these outcomes hypotheses, and there's actually two types. There's one called the null hypothesis, and then there's another called the alternate hypothesis. The null hypothesis is what we start with, and the alternate is basically the opposite. Some notation here, the null hypothesis always uses this symbol here. It uses a big H for hypothesis and a 0 for null. What the null hypothesis means is it's our beginning hypothesis. It's what we think is going to happen, and it's what we think the mean is going to be equal to. So in our class, the null hypothesis is always going to look like this. It's going to look like HO, a colon. We're always going to talk about the mean being equal to some sort of number. Okay, so maybe the mean is equal to 2, or in the card case, the mean is equal to 5. The alternate hypothesis looks like this. Big H for hypothesis, 1. The alternate hypothesis tells us that something else is going to happen. Okay, so it either can look like this, where the mean is less than a number, this number, or this hypothesis where the mean is greater than a number, or it can say that the mean is not equal to a number. Let's do some examples here. In this example, we have that boxes of a certain kind of cereal say that they're labeled as containing 20 ounces. That's what we kind of expect when we buy a box of cereal. Now, there's this inspector that thinks that the mean weight may be less than this, and maybe he does an experiment to figure out if this is actually true. This question is asking us to state the null and alternate hypotheses. Now, the null hypothesis always starts out with the same phrasing. It's going to be big H, 0, a colon, and mean equals. The null hypothesis will always look like this. Now, looking at the question, the number that we think that the mean is equal to is 20. So this right here is my null hypothesis. Going over to the alternate hypothesis, it's always going to start with an H1 colon, and we're still talking about the mean. The number of the alternate hypothesis is always going to be the same as the number on the null hypothesis. Now, thinking about what symbol it should be, it's either going to be a greater than, a less than, or a not equal to symbol. Looking at our question, it says that the mean weight may be less than this. So I'm guessing it should be a less than sign. So our null and alternate hypothesis always looks like this. They always have the same form. They always use the same number. The only thing that really changes is this value here. Okay. Example 2 is very similar. We're talking about the mean monthly rent for an apartment in a certain city, and it says that it was $800, which is pretty cheap. We say we have this real estate agent. And this real estate agent believes that the mean rent is actually higher this year. We want to state the appropriate null and alternate hypotheses here. So the null hypothesis always uses big H sub 0 with the colon. We're always talking about the population mean, and we're saying that it's equal to something. Looking at our question, $800 is what we're looking for. For the alternate hypothesis, we're using the same idea here. We're using big H1. We're talking about the mean. The number stays the same. And reading our question, it says that the mean rent is higher. which means I should use a greater than sign instead of a less than sign this time. Let's do a final example. We have that scores on a standardized test have a mean of 70. Now we did some modifications to the test, and now this educator thinks that the mean might have changed. Okay, next we're going to state the null and alternate hypotheses. Let's start with the null hypothesis. We're always going to start with H0 with a colon. We're always talking about the population mean. And in this question, it says 70, so I bet that's what it's equal to, isn't it? For the alternate hypothesis, we're using big H sub 1 with a colon, still talking about the population mean, still using 70. But in this question, it doesn't tell us less than or greater than or going up or going down. It just says changed. Because it doesn't tell us what direction it's changing in, we're actually going to use the not equal to sign here. Now that I think that we're a little bit more comfortable with the idea of our null hypothesis and alternate hypothesis, let's put this together and figure out what happens when we do a hypothesis test. When we do a hypothesis test, first we assume that the null hypothesis is true, kind of like how we assumed that the mean was going to be 5 in our card example. Then we're going to do an experiment and we're going to look at the evidence. Okay, so we're going to take a look at it and see how it compares to our hypothesis. Finally, we're either going to reject the null hypothesis or fail to reject the null hypothesis. So there's two options for us to do here. Okay, if we reject the null hypothesis, we have to write a conclusion in a very specific way, and we have to use the correct words for this. If we reject the null hypothesis, which means we don't want that hypothesis that we said in the beginning to be true anymore, we're going to say this. We conclude that the alternate hypothesis is true. So we're essentially accepting the alternate hypothesis, or the opposite of what we said at first. If we don't reject the null hypothesis, what we have to say is that there's not enough information or evidence to say that the alternate hypothesis is true. So in either scenario, we're saying something about the alternate hypothesis, H1, and we're either saying that we conclude that it's true or that there's not enough information to say that it's true. Okay. One thing I want to stress is we're not actually saying that the null hypothesis is true in either scenarios because we don't actually know if it's true or not. We're just saying that the null hypothesis might be true when we reject the null hypothesis. Let's do some practice with writing our conclusion. So in example 1, we have the same box scenario, okay? We know that the boxes of a certain type of cereal is labeled as containing 20 ounces. The inspector came in and thought that it was less. In the last examples, we said what the null hypothesis was and what the alternate hypothesis is. Now, in this example, the inspector rejects the null hypothesis, and we want to state the conclusion. Okay, when we reject the null hypothesis, wording is very important. Okay, now we said that when we reject the null hypothesis, we have to say that the alternate hypothesis is true. The way that we say this is very specific, and we have to say it the right way. We're going to say, we conclude that and then we're just going to write the alternate hypothesis down. So whatever the alternate hypothesis says, we're going to write that down. The mean is less than 20. So we're basically piecing together two phrases or parts of a sentence together. The beginning is going to say we conclude, and the second part is going to say the alternate hypothesis. I know I'm going out of order here, but let's go to example 3. Let's say we have the same serial example with our null hypothesis and our alternate hypothesis. In this scenario, the inspector does not reject the null hypothesis. So he looked at the evidence and he said, I'm not going to reject the null hypothesis. In this case, we're going to say this. There is not enough evidence to conclude that, and then we're going to take our alternate hypothesis and shove it at the end of the sentence. The mean is less than 20. So when we don't reject the null hypothesis, we're piecing together a different type of sentence. The beginning is going to start with, there is not enough evidence to conclude that. The end is going to be the alternate hypothesis. Okay. Let's go back to example 2. This is the restaurant owner, and he complained, and this is a restaurant owner that claims that the mean amount spent by diners at his restaurant is more than 30. Now they're already giving us the null hypothesis and the alternate hypothesis, and we're rejecting the null hypothesis. Remember, when we reject the null hypothesis, we always start our conclusion with, we conclude. So that's the beginning of our sentence. The ending of the sentence, no matter what the conclusion, is the alternate hypothesis. So we're going to stick the alternate hypothesis at the end of our sentence. Finally, for example 4, we have a veterinarian claiming that the mean weight of an adult German Shepherd is 75 pounds. We make a test where our null hypothesis is that the mean equals 75. The alternate hypothesis is that it changed. It's different than 75. If we don't reject the null hypothesis, we always start our conclusion with, there is not enough evidence to conclude. There is not enough evidence to conclude that. And I bet you know where I'm going with this. The ending of our conclusion is always the same, and it's always going to be the alternate hypothesis. So mu does not equal to 75. Again, we're piecing together our information. The first part depends on if we reject the null hypothesis or if we don't reject it. And the second part is always the same. It's always the alternate hypothesis.